This video is about creating objects. So in a previous class, we talked about how we can create any object we want using a class. The example that we used was a line. So we're going to revisit that concept and have a more thorough explanation. So I've created a class called line, and over here I have a class called line test. So if you want to follow along, create the same classes. So over in our class line, all right, so first, a class is a blueprint of an object. In this case, the blueprint of a line that we know from algebra. From this line class, we can create a lot of versions of a linear function. The classes always contain instance variables, which are just attributes of the object. In the case of a line, we're going to discover that we're going to have a slope and a y-intercept and an x-intercept. The methods that we want to write for our line object, they're things that, in addition to just returning information that we already know about it, in this case, again, the slope or y-intercept, what can be done to the line. In the case that we're going to see, we can return the equation of a line that is going to be perpendicular to that line. Given two lines, we can write a method that finds the intersection value of those two lines. We will be able to change the slope, be able to change the y-intercept, and even find the inverse of the line if we wanted to. So if you're writing methods, you always want to be able to answer the questions of what can the object do and what can be done to the object. As with all programming, once you learn how to create your own objects, the sky's the limit in terms of what you can create with this, and it unlocks the ability to do a lot of other stuff. So in our line, so we said that a line is going to have a slope and a y-intercept. So we're going to have first, we're going to make a private int, and we're gonna we'll call it double. So private double slope, and then we're gonna have private double y-intercept. So what we've done right now is, so inside of the class but outside of any methods, we've created what we call instance variables, and these are the attributes of any line object that we create. So every line that we create is going to have a slope, and every line that we create is going to have a y-intercept. These are the things that are they're important or inherent to our object. So for a line, that's all we need is a slope and y-intercept. Now again, when I say line, I just mean something of the form y equals mx plus b. Those are the lines. M is the slope, b is the y-intercept. So now that we have our instance variables, we can have a constructor for our line. So the constructor is always named exactly the same as the class. So we're going to have public, and in this case, line. Now, constructor is a method that, well, technically a method that creates our object. It does not return anything, and it can take parameters, or we can have what we call a no parameter or no argument constructor. So in the case of a no argument constructor first, we're just going to have public line. And if someone just created a line object, you would want a default value for it. So in this case, we're going to say this dot slope equals slope. Not slope. We want to make this a default value. So we're going to say by default, the slope of a line is going to be 1. We're going to have the line y equals x. So then this dot y-intercept is going to equal 0. So this is going to go through the origin. So over in our line test class, we're going to create an object. We're going to have line, and we're going to say my line equals new line. And so what we've done now is created a new line object. Right now, we can't do anything to the line object because we don't have any methods that allow us to get any information or do anything to the line. We have these variables that are marked private, double, and y-intercept. So if the variable was public, we'd be able to do something like print the slope of the line, or we could do my line dot slope. But what's going to happen is this error tells us that this is not visible. So if we go back over here for a moment and change this to public, and so now you see the error message went away. And when we save this and we run it, Control F11, we get, where's the console? I'm sick of having to reset the perspective. All right, so we'll close this, and for whatever reason, the console continues to go out of view. So when we run this, we get a slope of 1.0. Now that was because we went back and made the variable slope public, but generally you want to just keep this private, because if we have hundreds of classes that make one program work, you don't want all of those other classes to have access to the variables in one class, because debugging becomes a problem, and it makes the biggest reason is that it just makes debugging a nightmare if you don't know which of hundreds of classes that contains thousands of lines of code create the problem. So if that variable is private, it only really exists inside one class. So back over here, now we're going to get this error message again that is not visible. So if we actually want to access the value of slope, we need a method that's going to return that. So we go back over to our line class, and we have our no parameter constructor. So we're going to have public. Now to get the slope, we'll just call a method that gets the slope. So it's going to return a double. So public double get slope. And all we need this to do is return this dot slope. There are two reasons we use the word this. First off is generally you're going to want to name the parameters that you pass. They need to have clear names. And so generally the name that we pass as a parameter is going to be the name of the instance variable that we created. So if I have slope here and I need to refer to slope inside of a method, I need a different declaration, and this helps out with that. It does two things. One, it points directly to what we need it to, and it also only refers to that instance of that object. So instead of having to do something like slope equals slope 1 or something like that, where we come up with a different name for slope, we can just have this dot slope, and it always refers to the slope of the object that we created. You won't get any errors if you don't use this, but when you're taking an AP exam, you're going to see that any constructor is going to have this dot for an object. So anyway, our method returns slope, and I guess we should also have one that returns the y-intercept. So we're going to have public double get y. We'll make it y-int, and this we need to return y-int, this dot y-int. And this needs to have bubble. So now we have two methods that allow us to get the slope and the y-intercept. So if we wanted to, we could make a line that prints the equation of the line. So we can have the equation of my line is y equals, and so then we'll refer to the slope. So we're going to have my line dot get slope, which is going to return the slope value plus x plus my line dot get y-intercept, which is going to return the y-intercept. And I guess we need to make a grammatically correct sentence. So let's see what we get now. When we run this, we should get the equation of my line is y equals x plus 0. Well, 1.0x plus 0. We'll see. So that's exactly what we get, because right now we have a no parameter constructor that has defaulted to 1 and 0. So with this, what we can do is there are a couple of ways that we can change the value of our slope and y-intercept. One is that we can have a void method that sets the slope And so we'll need to pass a parameter double new value. And so we're going to say this dot slope equals new value. Nope. And we could have another method where we have public void set, we'll just call it set y. And we're going to say this dot y intercept equals, well, we need a new y, right? So we'll do new double new y. So now we have a method that changes the slope. We have a method that changes the y-intercept. So here, when we have our default constructor, the first thing we could do is, like, say you just created a line, but you didn't know what you wanted y-intercept or slope to be. It's going to default to 1 and 0 because of how we set our default constructor. But say later on in the program, you say, you know what, my line dot set slope, I want this value to be 5.6. And then, ooh, what's the issue? Oh, I didn't save this. So then a quick word, anytime you update the main class that's going to be feeding into the test class, always save this so you don't get any weird compile errors. Like if I change this to be, I don't know, we'll say 6 for instance. Over here, if I take away this parameter for a moment, if I come back over here and save this, I'm going to get an error because I haven't updated this to match what's going on over here, because now this set slope method doesn't have a parameter, and over here the set slope method does have a parameter. So anytime you save this, it needs to be, the parameters and things need to line up. So we're just going to undo the changes that we made over here so that we actually don't get any errors. But if you ever get any weird errors, first make sure that you save both files appropriately, and it generally gets rid of the compile errors. So then we could have my line dot set y, and we'll make this 7.4. So when we create the line, it's going to have a, you know what, we'll just do 2 lines so you can see what happens. So we're going to have 2 print statements. So when we create the line, we're going to have, first, the equation of my line is y equals 1.0x plus 0. But then we change the values of the slope and y-intercept and run the method again, and we get 5.6x and 7.4. So this is all without passing any parameters to the constructor. So you can change the values of your line object just by having methods that do that. Now, the second thing is that we can have as many constructors as we want for our object. So say when you create a line, you actually do know the value of the slope and y-intercept. So we're going to have a double for slope. We're going to have a double for the y-intercept. So now we're going to have public line y-intercept. I'm so used to typing it as a math teacher that I put the hyphen. So we're going to have public line, and we're going to have a double for slope and a double for y-intercept. So now we have a constructor where we can pass 2 parameters. So we're on this dot slope, which again refers to the slope of the object that we're creating, and it's going to equal slope. And so now we can see where the word this is useful, because we want to name our parameters so that they match the things that are up here. So we have slope, and to make it clear that we're referring to a different slope, then here we're going to have this dot slope equals slope, and this dot y intercept equals y intercept. That is the parameter. So we go back over to our line test, and we're going to we'll delete this, And so now we have line, my line, we'll just leave that. But now we have line, your line equals new line. And say we pass it a parameter of 4 for the slope and negative 2.5 for the y-intercept. So we can just do, so when we print the slope is, so we still have methods that get this. So we're going to have your line dot get slope. And when we run this, we'll get the slope is 4.0 because now we've created a line object where the parameters are slope and y-intercept. And we could write another print statement that prints that the y-intercept is whatever. So right now we have two constructors. We could have a third. You can have as many constructors as you want as long as the parameters are not in the same order and they're not equal. Like equal numbers of parameters in the same order is going to be redundant and create an error. So if we had like public line and I just switch the order where I have double y-intercept and double slope, now we'll see what happens. So you see how it's going to flag because it's going to be duplicate because both of these are doubles. And so it's not going to make a distinction between the fact that one's named slope and one's named y-intercept. And then we reverse it and we have double y-intercept and double slope. It's just going to see that the constructor has two doubles and that's going to throw up an error. But if we come along and just say, you know what, I want the slope this time to be an int. Now it's going to be fine. We still have two parameters, but they're not of the same type. So in this case, we won't get an error. But again, if you change this back to double, you're going to get an error because it's going to look redundant. So you can have as many constructors as you want as long as the parameters are different numbers and different. If you have the same number, they have to be different types along the way. So if we wanted to have a single parameter constructor where you're just passing the slope, then you can have this dot slope equals slope, and then you can just set the y-intercept to be some default value of probably 0.0. So now we're going to create three different lines. Over here, we already have my line, we have your line, and we'll just put their line equals new line. And so now we're just going to pass a slope, which we'll say is 1.5. So one thing that we can do since we've created our own objects is create an array of objects. So this will give us a chance to review enhanced for loops and see how you can create an array of your own type of object. So say we have an array of objects. So remember, we name an array by the type that it's going to hold. And arrays can only hold one type. So in this case, we're going to create an array of lines. So we're going to have line, and we're going to call this our lines equals. And so in this case, we're going to have new line and 3 because we have 3 lines in our array. So we're going to have our lines 0 equals my line, our lines 1 equals their line, and our lines 2 equals your line. So now that we have our lines in an array, we can make an enhanced for loop to print an equation. So let's see. So for an enhanced for loop, you have for the type of object. So in this case, a line object. So for line, and then we're going to say line, And we need to refer to the name of our array in this case. So it's going to be our lines. And what do we want to do? We want to print the equation of the line. So we're going to have the equation of the line is, then we're going to have, let's see. So the dummy name for this is line. So we're going to have line.get slope, get class, no, get slope, plus x plus line.get y-intercept. Cool. And we're just going to have a period at the end. So why is this an error? The method get slope is undefined for type string. Oh, I missed my plus. My bad. So now when we run this, we have done three things. We created 3 line objects. We created an array of those line objects, and we put all of those lines in our array, our lines. When we run this, we should get the equation of the line is 1.0x plus 0, 1.5x, and plus 0, and 4.0x plus negative 2.5. So far, we've created 3 different types of constructors, methods that do something to the line. In this case, we just return information. And so that's not really that helpful. But say you wanted to write a method that return the solution. So we could have public, we'll say double x intercept. And so all we need to do now, the x-intercept for a line is you set it equal to 0, so it's going to be b divided by the slope, or the y-intercept divided by the slope. So we need to return -1 times this dot y-intercept divided by this dot slope. So if we go back over to our line test, so we can have the equation of the line is this, and we can add in another print statement where we have, then we can say, and the solution is line dot, now we can get, what did I call that method? Xint. So line dot x int, and we pass it nothing. So we run this and we get the equation. The solution of the line is -0, -0, and 0.625. So far, that's all we're going to cover with creating our own objects. Later on, we'll talk about inheritance and extending classes so that we can write methods where our objects interact with each other based on methods that we write within this class.